Okay class, welcome to another video. Today we're going to talk about just different things to do with polynomials. So we've talked about a lot of this when it came to quadratics, but today we're going to talk about taking that up a notch to what we have here. So first thing we're going to look at is factoring. So we're trying to write this polynomial in factored form. I actually have two examples here. So in this case, I'm looking to just pull something out to make it easier to deal with. And in this case, that's really easy because I have an x cubed, x to the fourth, x to the fifth. So the lowest amount I have is an x cubed, so I bring it out front. And I factor it out of everything I have up here, which just gives me x squared plus 12x plus 27. What's nice about this is you've dealt with learning how to factor this. There's plenty different ways to try it. But you're just looking for numbers that multiply to give you 27, that add together to give you 12 to find your factors. In this case, that's 9 and 3. So at this point, you have x cubed times x plus 9 times x plus 3, and you're done. It's that simple. So let's move on to another case. This is just another one where you kind of got to see a trick to pull off here. I have x to the fourth plus 6x squared plus 5. One of the things I notice here is if this was squared and this was just a single x, it would be really easy to factor. So I'm going to just substitute a to equal x squared. It's going to change a little bit of what I'm doing, but the reason we choose this is because if I were to plug x squared back into something like this, I would get x to the fourth. So if I have a squared, you'll agree that that's x squared times x squared, which is just x to the fourth like we have up here. If I have 6 times a, that's the same thing as 6 times x squared. So that's just a different way to write it. And then I'll bring my plus 5 along. Well, once I get it down to this form, it's just a quadratic. So go ahead and factor it as such, which in this case is a plus 5, a plus 1. And then just substitute back in for your a. So I get x squared plus 5 and x squared plus 1. Just a quick and easy way to factor them. Okay? So let's move on to roots and multiplicities. There's plenty to talk about. So I'm just giving you this equation right here, and I'm asking you to find the roots of it. Well, it's not really an equation, it's an expression, but so I'm looking at this, I'm trying to find the roots. So you look at the factors. What we're basically doing here, it's nothing hard to do. It's just looking at this and saying, how do I get from a factor to a root? All that is getting x equal to something. So you take this and set it equal to 0 to solve over. All you would have to do is subtract 2 to both sides. That just gives me x is equal to negative 2. Do the same thing here, and I find that x is equal to 1. And I have this case right here where that's the same thing as saying x minus 3 and x minus 3. And I just get that 3 is the root. Now this is where we start talking about when something shows up more than once. So in these two cases, there's only a multiplicity of 1 because there's only one factor there. But these two, we have two factors of x minus 3. So what we say about it is it has a multiplicity of 2, and we say that that root is x equals 3. And just kind of a vocabulary type thing here, the multiplicity of a number the multiplicity is the number of times a root occurs in an expression or an equation. So it's just the amount of times it happens. In this case, it's happening twice because it's squared. Okay? Multiplicity is not that hard. Don't make it any harder than it has to be. So my next board, it's got two things on it. We're just writing a polynomial function from its zeros. So I've got root, and I meant to write root, so disregard from its 0. It's supposed to say from its root. So I have the roots of this are just x equals negative 2, 2, and 3. So talking in the last time, the way I would get a root is by subtracting something over or adding it depending on if it was positive or negative. Well, in this case, we're just moving it back over the other side to get my factors. So instead of having minus 2 over here, you're adding 2. Instead of having a positive 2, it becomes negative 2. And then instead of having a 3, it's minus 3. All I'm going to do in this case is then just multiply it out. So if I FOIL these first two, I'm going to notice that all I get is x squared minus 4 times what I had left over that I didn't do anything with, which is x minus 3. From there, I'm just going to multiply that back out, and this is what I get from it. So you can sit here and check the math on that just to get used to it, but nothing too hard there. The other thing is we're finding the multiplicity of a 0. So again, I talked about that in the last slide, what it meant to have a multiplicity. So in this case, we're just finding the multiplicity. So you're given an equation. You have to factor it down to be able to get all the factors of it. And once you have the factors, you can find the multiplicity. In this case, I have x squared. Another way to look at that is just x times the rest of this. And then you set each of your factors equal to 0. So if I set x equal to 0, that's going to be one of them. X equal to 0 again, because it's squared, that's going to be 0. And then I get x minus 4. Well, when I just add the 4 over, it becomes 4. And then when I have a positive 2 subtract over, it gives me negative 2. So these are two of the roots that have multiplicity 1. And then roots with the multiplicity of 2 is just 0. Okay? So for one of the last two boards, this is just graphing using the roots of an equation. And we kind of touched on this a little bit right before break when we talked about how to graph functions. This is just an easy way to look at it. If I had an equation, that would make it even easier, but I can graph something given the roots and just one other key piece of information, which is whether or not it's positive or negative. So if I'm told that this is all the roots I have, and I'm assuming that this is positive, what I'm going to look at is plotting my roots, so negative 2, 0, and 4. You see that 0 happens twice, so we'll keep that in mind and talk about what happens. And then I'm assuming it's positive. So if I have 4 roots, I know that talking from what I had yesterday, if I have 4 roots, my degree has to be 4 as well. So that's even. Now I'm assuming it's positive, so I know its end behavior is up and up. So to get that, I would have to have up coming down to this point, coming up here, and that's where I have this multiplicity of 2 for 0. At that case, what happens is when you have a multiplicity of 2, it's just going to bounce right off that point. So it goes right in and right back out again. So just right at that point. And then it's supposed to go up again, so I know that this function has to kind of curve back around and go up. So that's kind of how you're just using the roots. Now if you have an equation, what you'll do is you'll look in between negative 2 and 0 to find out whether or not this is positive or negative. So in this case, we would have plugged in and found out that it's negative to that point. Same thing happens between 0 and 4, and you find out it was negative as well. So that's how you're graphing just using the roots. Plot your roots where they're at. If it has a multiplicity, it'll bounce. Or in another case, I'll show you that really quick, just in case you run across it. If I had the multiplicity of a root, say, negative 2, 0, 0, 0, and 4, what that's going to change, now I've got degree 5, and let's just assume it's positive again. So here at negative 2, 0, and 1, 2, 3, 4. Those are my 3 roots. I'm assuming it's positive. Again, just like I did here. And this is an odd function now because I have 5 total roots. So I know that the way this usually acts, it goes from down and up. That's the end behavior, so I need to start down here. Here's what happens when you kind of come to something that has a multiplicity of 3 at its root. It kind of comes straight down like that, kind of like the cubed function itself. And then you're going to double back and come up here because that end behavior is supposed to be up. So that's just how you look at multiplicity of 3. Everything else past that, say something had a multiplicity of 4, it's going to act just like this did. It's going to bounce right off. In this case, anything 5, 7, 9, anything that has a multiplicity like that will do just like that, kind of like that little s. Okay. Well, last thing we have to cover, and this is probably one of the easiest things to see for your students. This is identifying the max and min of an equation. So I'm going to give you a calculator for these just to be able to get the graphs of them, because I just care about you seeing the graphs and kind of getting the information from it. So if I were to plug this equation into a calculator, I'm going to get this graph. When I get this graph, I just need to look at it. So if I were to just keep plugging in values this way, this graph's going to keep going down, 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 down. This graph, if I keep plugging in positive values of x, is going to go up and up and up. The points I care about are my max and my min. Now that's not the absolute maximum, that's not the highest point on the graph, and this isn't the lowest point on the graph. But what a relative max and min means is that just in a general area, you can tell that this is the highest point on the graph because all of these values leading up to it and all of these values leading away aren't as high up as that point. The same thing goes for here. So if I were to look from just that whole area right there, that's a relative min because all of these values are higher than that point. So that's how you're looking and just finding a relative max and min. These usually, if not always, occur at turning points, which we've talked about the past couple of days. So again, when you change from increasing to decreasing, you're going to have one of these. So like I said, if you need to come back and brush up on this before Wednesday's class, please do. We're going to cover a lot of the last 2 boards on Wednesday. And I hope you guys have a great day in class tomorrow. I will see you Wednesday. I'm not going to be here tomorrow. So you guys have a great night. Thank you for watching.